So now that we know a little bit more about Bohr's model of the atom, it's time to learn how to draw one. Now, previously, we started to understand that Bohr had energy levels, areas where electrons would live, and that there was a distinct amount of space between them that would represent a quanta of energy. So let's get down to how we actually end up drawing this for specific elements. Of course, like any good chemistry student, we're going to need to start with the periodic table. Now, one thing that I did want to remind you of is what a period on the periodic table actually is. Now, a period is a row on the periodic table. Here are just a couple as an example. I would like you to understand that a period on the periodic table essentially represents an energy level or a shell in Bohr's model of the atom. Now, before I go anything further than what I have highlighted on the screen, I just wanted to let you know that we're only going to be drawing Bohr model of the atoms for up to and including atomic number 18. Without some further understanding, the Bohr model is not really going to work for how we're going to learn how to do this. We're going to learn a little bit more about what goes on using Bohr models later on for atomic numbers beyond 18, but we need to understand a little bit more about matter and energy first. So here we go. Each level in Bohr's model of the atom can only contain a certain number of electrons. You're going to need to remember these numbers, that the first energy level can only contain 2 electrons, the second energy level can contain 8 electrons, and the third energy level can contain up to 18 electrons. That's a lot. So let's take a look at a very specific element to start to build a Bohr model. Let's start with my favorite element, carbon. Now, carbon is atomic number 6. That means that it has 6 protons. And if it's a neutral element, which this one is, it will also have 6 electrons. Now, there's only one subatomic particle left to figure out, and that's the number of neutrons. Now, last chapter, we should remember that the atomic mass down at the bottom of most of these element tiles represents the number of protons plus the number of neutrons. So if you'd like to figure out the number of neutrons, you simply need to subtract the 2 numbers on the periodic table. In this case, 12 minus 6 would give us 6 neutrons. So now we know the 3 numbers for the 3 subatomic particles that are in carbon: 6 protons, 6 electrons, and 6 neutrons. The last piece of information that we're going to need to know is simply based on carbon's position on the periodic table. Because it's in the second row of the periodic table, that means that carbon is going to have 2 energy levels of electrons. Let's get started drawing it. So here's just a little summary of the information that we know. 6 protons, 6 electrons, 6 neutrons. And I've drawn a little blue circle in the center of the screen. This is going to represent the nucleus. And again, as you may remember from last chapter, there are 2 particles that go on the inside of a nucleus: the protons and the neutrons. So we're going to note how many of each we have inside the nucleus. I'm going to do this simply by saying P, representing the number of protons, equals 6, and N, representing the number of neutrons, equals 6 as well. Now, again, remember, carbon has 2 energy levels. Let's draw those in as well. So here's the first energy level and the second energy level. All we need to be doing is placing electrons on these energy levels. Remember that there's only 2 electrons allowed on the first shell, but we have 6 total to place. Now, you can't put anything more than what's allowed on an energy level. So we're going to have to simply note that on this first energy level, this first shell, there are 2 electrons. What does that mean for the rest of the atom? Remember, we have 6 total electrons to place, but we've already placed 2 of them. That means that we have 4 electrons left to put into my model of the atom. Luckily, there's a second shell. So we're going to start to fill up the second shell. In the second shell, we can fit up to 8 electrons. But there's one big thing that you're going to need to remember. You actually don't need to fill up the outer shell. Essentially, in this outer shell, you're only ever going to be placing the number of electrons that you have left over. So you can have anything in this particular shell, shell 2, less than or including 8 electrons. So we're simply going to put those 4 electrons that we have left over in the outer shell, and here we've successfully drawn a Bohr model of the atom. Now, just to make sure that you've got this down, let's try this with another element. How about with sodium? Now, here's sodium's information lifted right off of the periodic table. From this bit of information, I'm hoping that you can recognize that we should have 11 protons, 11 electrons, and if you subtract the two numbers on the periodic table, roughly 23 minus 11, you should have about 12 neutrons. Now, that's a lot of information, but it's not everything else we need. The last bit comes from its position on the periodic table. So we find sodium and recognize that it's in the third row down. That means that sodium has 3 energy levels. Time to start drawing. So we start again with our nucleus. We're going to place our protons and our neutrons on the inside, 11 protons and 12 neutrons. Now let's draw in our 3 energy shells. We start in the first shell, remembering that we can only put 2 electrons in there. So we're going to put 2 electrons in our first shell, and let's see how many we have left over to place. We had 11 electrons total. We've now placed 2 of them. That gives me 9 electrons left to work with. Time to move out a shell. Let's fill up the second energy level. Now remember, in the second shell, I can place all the way up to 8 electrons. So let's fill up that second shell. So we're going to put 8 electrons into that second shell, and let's see how many electrons I have left to deal with. So if I had 9 electrons left at the point where we filled up the first shell, and I just used an extra 8 electrons, that gives me 1 electron left to place. Again, the outer shell doesn't need to be completely filled up, but we do need to remember that in that third shell, we could put upwards of 18 electrons. That's plenty of room. So we only have that 1 electron left. We're simply going to put it on the outer shell and call it a day. I hope you have some success with drawing Bohr models of the atom.